Hello Year 11 and welcome to the 5th video here in the series on probability. In our last exercise we looked at relative frequency, the number of times something happens divided by the total number of observations, the total frequency. And we used that to determine experimental probability. Now experimental probability and theoretical probability that we've been working out before that are not the same thing. Now consider this situation. If I flip a coin 4 times and it lands on heads once and tails 3 times, if I was to work out the experimental probability of heads based on that, then I would say the experimental probability is the relative frequency of 1 over 4. I know that the theoretical probability, right, of landing on heads is 1 over 2 because they're equally likely outcomes. Okay, this is not to say that my experiment was wrong, but the problem is that I haven't done enough trials. Okay, the more trials I do, the more reliable that comes. Now I've drawn up a tree diagram here to show what might happen if I flip a coin 4 times. Okay, now this tree diagram will give us the theoretical probability of the outcome of flipping 4 coins. Now in yellow here you can see, whoops, what's happened there? In yellow, we'll zoom out a bit. In yellow you can see that there are, what have I got there, 4. 4 out of those 16, 4 of the 16 outcomes have 1 head and 3 tails. Right? That's really not that unlikely to occur. Only 6 of them have an even balance of 2 heads and 2 tails. Right? That I can't expect that if I only do 4 trials that I will get 2 heads and 2 tails. Right? That my relative frequency is inaccurate or unreliable because of the number of trials. If I complete more trials, right, if I flip that coin more and more times, then I'm going to get an answer that's closer and closer to the theoretical probability, a much more reliable result. And this is the basis of a lot of science, really. Lots of scientific experiments is that you need to do it a lot of times to make sure that your results are reliable. So here we go. Mary flips coin 5 times. Every time it's landed on heads, what is the most likely outcome of the next flip? Well, this is called a gambler's fallacy, I think it's called. And you might see people playing 2 up on Anzac Day or betting on the roulette wheel perhaps at the casino when you get old enough. And you might see people make this decision, well, there's been a lot of heads, must be due for tails to come up and even it out. Not the case at all. Okay, what's happened in the past for these independent events won't affect what happens next. It's a regular coin, might have landed on heads 5 times, but the most likely outcome, well, in fact, there's no most likely outcome. I have an even chance, that is a 0.5 chance of heads or tails. Right? We have an even chance, I better write this in, an even chance of heads or tails. Okay, this idea of a law of averages, that they must balance each other out, can be misinterpreted. That if I do enough trials, then the differences between the number of heads and the number of tails will become less significant. Okay, that I might have 2 more tails than heads, right? But 2 out of 100 is much less significant than 2 out of 4. 2 out of 1,000 really has very little impact compared to 2 out of 4. So we make our experimental probability more reliable by conducting more trials. That's really all there is for this. We might do some experiments in class to do some observations about this, but that's it for this video. and I will see you in class.